Hi, my name is Joe Malinka for those of you who don't know me, and I'm really excited to be at SAINTCON this year. I want to start off with a brief analogy. Let's suppose for a moment that you walked into a hospital and they wanted to draw some blood because of some emergency. And they said, well, we're really sorry, sir, or we're really sorry, ma'am, but we're running really low on needles. And we have to reuse needles. We're doing a pretty good job sterilizing them. We think they're clean, but we are reusing needles. What would your response be? Yeah, I'll pass. I'll see you later. I'll just go find another hospital. Thank you. Yet that's what we do with our laptops, day in and day out, right? We open email attachments. We go to different websites. We sometimes plug in USB devices. Might even turn on Bluetooth. And unfortunately, that means eventually, at some point, our machine is going to get infected. So, for those who are familiar with Google and their BeyondCorp model of zero trust networks, I've been thinking a lot lately about how that applies to endpoints. Could you have an endpoint that is not only segmented but micro-segmented? Or could you have it so that you can isolate every single user click so it's micro-segmented? Right? Could you have it so that every time a user clicks on something, they get a brand new needle, if you will, or a brand new laptop that renders the content for the user and then disposes of it afterward? So this concept of disposable needles or disposable nitrile rubber gloves, or for those who have kids, disposable diapers, should be able to apply to something like a laptop to provide you with hygiene that allows you to always maintain a clean machine. So there are certain constructs in the CPU itself that allow you to attain a zero trust model, a micro-segmented model on that laptop. And most laptops have this today. So I'm going to skip out here and open a new tab, and we'll head over to arc.intel.com. So this is the architecture website where you can look at different technologies and Intel's chipsets. The same holds true with AMD. How many of you, by show of hands, are familiar with Intel VTX or AMD V? Anyone? Okay, so we've got a number of people here. So those CPU advanced technologies were created to be able to speed up the processing of virtualization, so you wouldn't have to rely on software emulation or pair virtualization to achieve this level of virtualized environment where you can highly segment it. If you look at the specifications of some of these chipsets, so for example, I'll just type in the CPU that is on my laptop right here. I have an Intel Core i5 6300U. And if we scroll down here, you can see it's about a 2-year-old chipset. We get into the advanced technologies. Now, this is where you start to see some of these more recent chipsets like the i-series, i3, i5, i7, some of the latest Pentiums, a lot of the Xeon processors for the last 5, 6, 7 years have had these types of technologies on it. But there's one additional technology that allows you to have a truly seamless virtualized experience that performs copy on write, and that's generically called second level address translation, or SLAT. Intel's interpretation of this or implementation of this is called EPT, extended page tables. And AMD calls this RVI. So what this allows you to do is essentially fork not just running processes, but running VMs, so that you can have for each process or each task that's instantiated by a user, you essentially fork off a brand new VM that can then be altered in any way, shape, or form by the content that's been rendered in it. And the alterations, the memory pages that are altered, or the files themselves, are written out to these memory pages that are mapped exclusively to that VM through Intel EPT. So in these virtualized environments, VTX now allows us to enforce the concept of least privilege as it applies to file and print, desktop, and network services. What that means is that when I click on something, a lightweight VM is instantiated that has least privilege applied to it. So it can render the Word document or the PDF, it can render the executable, it can render the website, whatever it might be. But that particular VM is unable to see the host operating system, just like a true Type 2 hypervisor would do. And it is also impossible to see anything on the intranet, the network. It's like each one of these VMs are out in the DMZ. So I have a little utility here on the right-hand side that shows these lightweight VMs that are running to be able to have this temporary, ephemeral, disposable computing. So if I want to go to a new tab here, let's say I want to go and do some online shopping. As soon as I hit Amazon, for instance, it gets rendered in one of these lightweight micro VMs. In this case, it's micro VM 74 here. Okay. If I'm done here and I want to go and look at sports scores, I can go to ESPN.com, and you'll notice that on the right side of the screen it shows micro VM 79 just got created just to render ESPN.com. And so in each one of these micro VMs, VTX is enforcing least privilege. To prove that, I'm going to launch a command shell inside of these micro VMs. One of them in particular, I'll run it in the ESPN micro VM here. So I'm in developer mode. I'm going to spawn a command shell. And again, this is, you can tell this is inside the micro VM because I can't get this command shell to come out, right? So the very first thing that attackers like to do, they want to see what credentials do I have? What's the user profile here? What's my IP address? So if we poke around a little bit inside this VM, we can see Intel VTX at work. I'll type ipconfig, and you can see that my IP address is a Microsoft Auto Configure IPv4, 169.254.2.15. Okay. Now on my real host system, if I spawn a command shell and I type ipconfig, you'll notice that my real IP is a 10.10 IP address, 10.10.247.238. Okay? The next thing attackers will try to do oftentimes is steal credentials to do a pass the hash. Yeah, is there a question right here? Yeah, so great question. The question is, how do I download things if these micro VMs are actually separate from my operating system? And I'm going to answer that in one more minute here. Okay. So the next question that attackers might say is, what's my user profile? You know, what passwords can I steal here? So if I dir the users directory here, let me go back up one directory. There we go. You'll notice that there's just this one user here, this BR user 1729. Now, if I do that on my real host system here, and I cd to the users directory, you'll notice that that specific user does not exist here. Okay. So, in essence, there's a fake IP address, there's a fake user profile, and I just have access to what looks to be a generic Windows operating system with just kind of bare bones applications running. Now, before we go any further, I'll answer that one question that you had about downloading files. So let's go over here and go to Google. We'll just type file type XLSX from sitestar.ru. In other words, we're saying, hey, Google, give me spreadsheets from Russia. Okay. Don't try this at home unless you're really confident in your ability to rebuild machines. So we'll skip over here. Let's just find some random file. Here's one that's Cyrillic, and I don't read Cyrillic, so I have no idea if what I'm doing is safe or not. I'm sorry? So I'll go ahead and click Save here. And that just downloaded right here to my desktop. Hit Properties. Just to show you this, there's no smoke and mirrors here. This file really did just get downloaded just now. And if I double click on that, this opens up in microvim number 81. Okay. And it gets rendered, again, VTX enforcing least privilege or micro segmentation just around this particular piece of content. If I close this spreadsheet, that microvim 81 is destroyed. If I launch it again, this time it launches in microvim number 82. Okay. So I'm always getting this, just like you'd expect a brand new needle, never been used before at the hospital. Here you get a brand new machine, and as soon as it's done being used, it gets destroyed. So what's really going on under the covers is that we write the distinct bit sequence that makes up that file. We write it down to the NTFS file system, but we tag it with its date of provenance information. We say, this file, it came from the outside. We don't know if it's good or bad, and frankly, we don't care, because the CPU, VTX and EPT, is isolating this file from the rest of the system, so I don't care if it's bad. Okay? And I can make changes to it as well. So if I want to type in, I don't know, this cell right here, I'll type in SAINTCON 2017. And we'll just go ahead and highlight this, and we'll make it nice and big. And then we'll go ahead and close this file. And here I'm prompted to save it or not save it. I want to save it because I'm a user that's editing this for some legitimate purpose. As soon as I do that, though, microvim 82 gets destroyed. But before we destroyed the microvim, we pulled out the file, including the changes, wrote that to disk, and make sure that the file retains its unknown provenance metadata. So if I double click on that file again, instead of microvim 82, now it's microvim 83. And you can see that my changes persisted. Okay? So users can handle files that are malicious without them knowing it and without needing to go and reimage or rebuild the machine. So this approach gets rid of the whole detection play. If you look at the evolution of detection, 15 years ago you had signatures, blacklisting, whitelisting, heuristics, and then it evolved into behavioral analytics. And then it evolved more recently into machine learning, artificial intelligence, and deep learning, those types of things. But mathematicians that are brilliant, much smarter than me, with PhDs, have mathematically proven that it is impossible to have perfect detection. There will never be a day when we can drive a stake into the ground and say, we've arrived. We will never again have false positives or false negatives. Okay? So this approach of the zero trust endpoint model gets around all of that because we're assuming every single user click is malicious. We're assuming every single email attachment they open, every single website they visit, everything launched off a USB stick, everything they download from the web, everything is malicious. And if you make that assumption, you never have to worry about false positives or even false negatives. Question? Is this part of Google's zero trust approach? They use, or is this an additional thing? No, this has nothing to do with Google. I spoke about Google's BeyondCorp as a model for zero trust networks. This is a model for zero trust endpoints, and it's not affiliated with Google. Yeah. Okay. Another question? Mm-hmm. You don't need to, because inside that micro VM, the question is, if I do stumble upon malware, maybe I'm using an old browser or something that's unpatched. I oftentimes will use Java 7 Update 5 because it's highly exploitable. Office, maybe you have an Office patch, or in this case, I just saw earlier today, I just ran into a new CVE that was seen in the wild. Right here. New Office 0-day. That was discovered just a week or two ago. Right? So what happens when I do encounter something that's malicious, that exploits either the application or the underlying operating system? So let's do that. I have here a bunch of malware. My favorite piece of malware, though, is a specific resume. And we'll just actually download it right here. I'll put it back. So I'm going to double click on the resume. And you can see here that this Word document just got open in microVM number 85. Okay. This resume actually does contain WannaCry ransomware, so it's about to post that up on the screen that I have to pay, $300 US in Bitcoin. But again, regardless of what it's exploiting, this whole Intel VTX and EPT thing, again, VTX for least privilege and EPT for read-only copy on write, is sitting underneath the operating system. So whatever happens in the operating system becomes irrelevant. So users, when they see this, they might say, hey, why can't I see my file anymore? So they'll move this out of the way, and then they'll keep looking at their resume. And then after they're done looking at their resume, they'll close the file, and microVM 85's gone. So the really interesting thing here is that once you've arrived at a point where you can do this micro segmentation, this hardware-based isolation, users can click on anything with reckless abandon, literally. Most people are uncomfortable with that. You can get rid of some portion of your stack of endpoint security products. I'm not saying get rid of everything because it's good to have layers, right? But because of the very high signal-to-noise ratio that occurs in each of these micro VMs, right? I mean, if I'm looking at microVM 79 and I all of a sudden see, a massive number of DNS lookups and a bunch of TCP connections open up, then I know that there's probably some advertisement on ESPN's website that has a clickjack attack embedded in it, and it's making all these TCP connections outbound. And the reason why I know that is because that's all coming from microVM 79. I don't need to go and figure out, okay, was it a Windows update that did this? Was it a user that did that? Was that, some application that did it? Well, there's only one thing running in each of these micro VMs. And so I know exactly and immediately which one's malicious. So in this case, if I go to my threat screen here, it turns out that the best place to look at malware is inside of these little detonation chambers, these little micro VMs. And the reason for that is because that one thing is running in it, and so we can just record the whole thing. We can just DVR the whole session. Like a black box flight recorder sitting on an airplane. What happened? And so as a result, you get to see, well, let's look at something that's a little more interesting. So for example, this one right here. This is the Word document that had the malware payload in it, right? You can see what time it happened, how long the micro VM was open for, what machine, who was logged in, the URL that the user clicked on, the file that they opened. You can see a categorization of the behavior. In this case, we saw some crypto malware, some C2, privilege escalation, etc. Then you can see where it beaconed out to from a CNC perspective. And finally, the full kill chain. So you can see play by play what the attackers did, because it's incredibly easy to watch them. So I like to say we turn the table on the attackers in this model, right? Instead of us trying to detect them moving silently through our environment, they're doing whatever they want, but it's inside of this micro VM that we're watching with a magnifying glass. So we can see, for example, when something gets dropped and executed, and then we can actually say, hey, I want that binary. I want that one of 4.exe. So I can just click up here, say, give me the malware itself, and then I can drop that into like IDA Pro and start reverse engineering it to see who's knocking on my door. So instead of spending hours of time, 4 to 8 hours on each incident of pulling prefetch files and memory dumps and figuring out who's knocking on my door, who's trying to infect me, and how did they do it? And then I have to go dispatch the desktop team to re-image the machine. And I have to go have the IR team, the forensic team, the analyst, try to figure out what happened and what it did. All that work is done automatically because these little micro VMs are little detonation chambers with DVRs running in them. So it becomes very easy to go a lot faster in terms of IR handling. And the best part is, you don't have to re-image machines. You can get out of that business. You can get out of the whack-a-mole security that is the endpoint space in this day and age. Question? The question is, do you need extra RAM on your machine to run all these micro VMs? And the answer is no. I've actually taken on my 8 gig machine, I've taken it all the way up to 110 micro VMs running concurrently. And I was using 4 gigs of RAM, including the host operating system. So I still had several gigs left over. No, because you're forking off the underlying operating system to render content and then destroying it. You're not using it on a long-term basis. Question? So the question is, do you see a heavy hit on any other resources like RAM or disk? Disk, no, because we're not doing any scanning. This is just standard I/O. Write a file to disk, read it. On the CPU side, you'll see about a 1% to 2% overhead hit. So, another question? Okay, so the question is, what if I have a legitimate need to download a file that does need to access my intranet, for example, right? So let's take the use case of like a finance guy who downloads an Excel spreadsheet, and then that spreadsheet needs to connect to some internal ODBC connection, right? Well, if it comes from an external connection, right, like some Russian website, right, the likelihood of that needing to legitimately access an internal database would be pretty low. So we look at the source of where it comes from. And the definition by default is, if it's on the intranet, it gets to access intranet resources if it came from my internal network. But if it comes from the outside, there should be no legitimate need that it needs to access an internal resource. So there's little things that you can tweak if you do need to make an adjustment, like you need to say, yeah, there's that browser plugin that does legitimately need to do that. So you can just tweak that and allow that access. Yeah, it's trust or untrust. And typically we trust the internal network and we untrust anything that's not on the internal network. Another question.
So my finance department wants to use Dropbox instead of the internal file share. So you're saying I could whitelist that, or I could leave it blacklisted and break their. Let's speak to that.
Right. So question is, what about like Dropbox? If I have a department that needs to rely on files on Dropbox, and the answer is yeah, you would typically say that specific OU group, that OU, they can access Dropbox in a trusted form, or you could say, you know, the files they access, they can copy, print, paste, edit. Do we need to trust them? And so you just leave them in micro VMs and let them do their work. In my line of working with this, I very, very rarely have to trust anything. It's a maybe once every year or two exception. I mean, it's very rare. So there was one other question back there. Okay. Huh? Yeah, it's in a policy engine. Yeah. Yeah, so Bromium is the software created by the guys who created the Zen hypervisor. So the Zen hypervisor powers Amazon AWS, Rackspace, Gmail, a bunch of these cloud SaaS providers. And so the next step was to take virtualization, strip it down, security focused, lightweight, onto the endpoint so that it's doing this zero trust endpoint, this micro segmentation on laptops and desktops. That's right. Yep. So the hardware has to support it, but pretty much any CPU manufactured in the past 5, 6, 7 years should have those necessary extensions for the hypervisor to hook into it to provide that least privilege. But your question earlier was, where do you set this in the policy engine, right? And that's basically right here. So you'd go into web browsing and you'd say trusted websites. So, you know, I'd want to say Dropbox. Oops. Dropbox.com. And then, but then you'd set that just for that specific set of users. You wouldn't set it company-wide, right? So, any other questions? Yes. This is for keeping malware from the outside from establishing a footprint on the network. This is not going to stop like an internal rogue employee from moving laterally across the network. Question?
But as a follow-up to that,
Mm-hmm.
if the rogue employee, or even if he does it accidentally and it hits my computer now, but I'm potentially not in that group, or is there any way to say once it hits my computer it falls into a trap, into a VM?
No, if it's already inside the system, this approach is not going to help you. That's where segmentation from a network perspective would help, and products that focus on internal attacks. This is purely focused on external attacks, or when users download stuff or plug in USB devices or open email attachments. That's what this is focused on. Yeah, Windows, and then we have an OS X release that's currently not available at this moment, but that should be out soon. I don't know. I don't have a date for you. Linux, I'm sorry? Windows 7 and later. Linux, there's no Linux support right now. There hasn't been sufficient demand for it. First of all, there's very few Linux machines in a lot of environments out there. And second of all, it's very rare for them to get compromised. So, any other questions? All right, thank you very much and have a good evening.